A scientist who's skeptical about climate science, or at least about a lot of what passes for climate science, which would of course make him another crackpot conservative. Or not. He served as undersecretary of the Department of Energy in the Obama administration. Steven Koonin on Uncommon Knowledge now. Welcome to Uncommon Knowledge. I'm Peter Robinson. Now a professor at New York University and a fellow at the Hoover Institution, Steven Koonin received a Bachelor of Science degree at Caltech and a doctorate in physics at MIT. During a career in which he published more than 200 peer-reviewed scientific papers and a textbook on computational physics, Dr. Koonin rose to become provost of Caltech. In 2009, President Obama appointed him Undersecretary of Science at the Department of Energy, a position Dr. Koonin held for some 2.5 years, during which he found himself shocked by the misuse of climate science in politics and the press. In 2021, Dr. Koonin published Unsettled, What Climate Science Tells Us, What It Doesn't, and Why It Matters. Steve Koonin, welcome.
Wonderful to be talking with you, Peter.
The shaken secretary. In Unsettled, you write of a 2014 workshop for the American Physical Society, which means it's you and a bunch of other people who I cannot even begin to follow, serious professional scientists, in which you and several colleagues were asked to subject current climate science to a stress test, to push it, to prod it, to test it, to see how good it was. From Unsettled, I'm quoting you now, Steve. I'm a scientist. I work to understand the world through measurements and observations. I came away from the workshop not only surprised, but shaken by the realization that climate science was far less mature than I had supposed, close quote. Well, let's start with the end of that. What had you supposed?
Well, I'd supposed that humans were warming the globe. Carbon dioxide was accumulating in the atmosphere, causing all kinds of trouble, melting ice caps, warming oceans, and so on. And the data didn't support a lot of that. And the projections of what would happen in the future relied on models that were, let's say, shaky at best.
All right. Former Senator John Kerry is now President Biden's special envoy for climate. Let me quote to you. This is John Kerry in a 2021 address to the United States, to the UN Security Council. John Kerry, 2021 to the UN Security Council. Quote, net zero emissions by 2050 or earlier is the only way that science tells us we can limit this planet's warming to 1.5 degrees Celsius. Why is that so crucial? I'm still quoting Kerry. Because overwhelming evidence tells us that anything more will have catastrophic implications. We are marching forward in what is tantamount to a mutual suicide pact, close quote. Overwhelming evidence, science tells us. What's wrong with that?
Well, you should look at the actual science, which I suspect that Ambassador Kerry has not done. You know, the UN puts out every 5 or 6 years assessment reports that are the IPCC, the Intergovernmental Panel for Climate Change,
right,
that are meant to survey, assess, summarize the state of our knowledge about the climate. The most recent one came out about a year ago in 2022. Previous one came out in 2014 or so. And when you read those reports, they're massive. The latest one is 3,000 pages, and it took 300 scientists a couple of years to write. And you really need to be a scientist to understand them. Even I, as I started to dig into climate science, I got a background in theoretical physics. I can understand this stuff. It took me a couple years to really understand what goes on. Now, Ambassador Kerry, other politicians certainly have not done that. But when he's getting his information, perhaps from the summary for policymakers in those reports, or more likely for an even further boiled down version. And as you boil down the good assessment into the summary, into more condensed versions, there's plenty of room for mischief. And that mischief is evident when you compare what comes out the end of that game of telephone with what the actual science really is.
All right. Now, what we know and what we don't. Let's start with what we know. Unsettled, I'm quoting you again, Steve. Not everything you've heard about climate science is wrong. In particular, you grant in this book 2 of the central premises or conclusions of climate science that are in the air that the press is always telling us about. Here's one, and again, I'm going to quote you.
Sure.
We can all agree that the globe has gotten warmer over the last several decades. No debunking, no debunking there needed.
And in fact, it's gotten warmer over the last 4 centuries.
Okay, now that's a different assertion.
Well, yes, that's correct, but it's equally supported by the assessment reports.
All right. All right. So that we'll have to come back to that because the time scale is
important.
It's one thing to say, oh my goodness, in my own lifetime, the climate of the surface of this planet, and it's an entirely different thing to say that beginning 150 years before this nation was founded, temperatures began to rise. This is something that's all right.
Yeah. It's a different statement, but it's equally true and has some bearing on the warming that we've seen over the last century.
All right. Here's the premise that you do grant. Again, I'm going to quote Unsettled. There is no question that our emission of greenhouse gases, in particular CO2, is exerting a warming influence on the planet. Close quote. We're pumping CO2 into the air, into the atmosphere. CO2 is a greenhouse gas. It must be having some effect.
Of course. Absolutely.
That's as far as you're willing to go?
Yes.
Okay.
Well, I mean, you tell me the next one.
Okay, here's the next one.
All
So
right.
but then you say, so actually those are pretty 2 anodyne premises that you grant.
Correct.
The Earth has been warming, and it's been warming for a long time. CO2 is a greenhouse gas, and it must be having some effect.
It's coming from human activities.
And it's coming from human activity.
Mostly
All right,
fossil fuels.
All right. Now on to what we don't know.
Okay.
Again, Unsettled. Even though human influences could have serious consequences for the climate, they are small in relation to the climate system as a whole. That sets a very high bar for projecting the consequences of human influences, close quote.
Right.
That is so counter to the general understanding that informs the headlines, particularly, we'll come to this, but particularly this hot summer we've had. So explain that.
Yeah. So human influences, as described in the IPCC, are a 1% effect on the radiation flow, the flow of heat radiation and sunlight in the atmosphere. 1%. Okay? That means your understanding had better be at the 1% level or better if you're going to predict how the climate system is going to respond. And the 1% makes sense because the changes in temperature we're talking about are about 3 degrees Celsius,
Right.
whereas the average temperature of the Earth is about 300 degrees Celsius. So it's also...
Wait a minute, the average, you mean at the very core?
No,
What?
the average temperature of the surface of the Earth is about 300 degrees Kelvin.
Oh, Kelvin.
Did I say Celsius?
You said
I'm sorry.
Celsius.
No,
Sorry.
no,
Okay. All right.
Kelvin, okay?
Which is what in Fahrenheit or Celsius? Give me-
About 55 degrees Fahrenheit,
Okay.
okay? 15 degrees Celsius,
All right.
okay?
All right.
So, 1% change in the temperature, you might think is about a 1% change in the radiation. So human influences are a 1% effect on a complicated, chaotic, multi-scale system for which we have poor observations.
All right.
All right?
You're saying things that are going to get you in trouble, Steve.
Well,
Koonin.
I like to say things that are right there in the IPCC.
Okay. All right. So now let's continue with what we don't know, one of the
Okay.
great themes of this book. Let's start with that IPCC, the Intergovernmental Panel on Climate Change. I realized as I read the book that I've heard it quoted over and over and over again and didn't even know what it stood for. So you
that's
explain.
good.
You
Good.
take a moment to explain it. I'll do this quickly. There are 195 countries that nominate scientists to assess climate research, and they do these assessments in cycles that last 6 or 7 years. As you said a moment ago, the last cycle ended about a year ago.
Right.
At the end of each of these cycles, which begin way back in 1988, they publish a report. Unsettled. Most of the disconnect comes from a long game of telephone that starts with the research literature and runs through the assessment reports to the summaries of the assessment reports and then on to the media coverage. There are abundant opportunities to get things wrong, close quote. So let's start at the very beginning, the IPCC itself. You served as provost of Caltech, so you know that you put together 6 academics on a committee and you've already got politics.
Yes.
You've got it. That's academic life. How can it be that this committee, the IPCC, nominated by 195 countries, which means 195 parochial interests at play, how can they produce anything that's any good in the first place?
Well,
and yet you seem quite relaxed about the original science.
The underlying science is expressed in the data and expressed in the research literature, the journals, the research papers that people produce, the conference proceedings, and so on, all right? The IPCC takes those and assesses and summarizes them. And in general, it does a pretty good job.
They do a
at
fair
that
job of
level.
that.
Yeah, and there's not going to be much politics in that, although they might quibble about, among themselves, about adjectives and adverbs. This is extremely certain, or this is unlikely, or highly unlikely, and so on, all right? But by and large, it's pretty good.
Okay. You're a professional, you look at this and you say this is done by fellow professionals in a professional manner. All right. Now things begin to go wrong.
Right.
Where?
So the next step is nobody who isn't deeply in the field is going to read all that stuff, all right? So there is a formal process to create a summary for policy makers, which is initially drafted by the governments, not by the scientists. And
Wait a minute. 109 representatives of 195?
Well, it's not, of course, all of them don't participate. In fact, all the scientists who are listed don't participate in everything. There's some subcommittee, right, that is meant to do the summary for policymakers. And that gets drafted and passed by the scientists for comment. Some of them grumble, okay? But in the end, it's the governments who have approved the summary for policymakers, line by line. And that's where the disconnect happens, first disconnect. I'll give you an example.
Please.
All right? So you look at the most recent report, and the summary for policymakers is talking about deaths from extreme heat, incremental deaths. And it says that, extreme heat or heat waves have contributed to mortality. Okay? And that's a true statement. But what they forgot to tell you was that the warming of the planet decreased the incidence of extreme cold events. And since 9 times as many people around the globe die from extreme cold than from extreme heat, the warming from the planet has actually cut the number of deaths from extreme temperatures by a lot.
And that doesn't make it into
No, that's not in there at all. Okay, so the statement was completely factual, but factually incomplete in a way meant to alarm, not to inform.
All right. And now so it goes to these policymakers, and then John Kerry stands up and gives a speech, which is...
Yeah. Well, maybe he read the SPM, I don't know.
Or his staff read it.
His staff read it, and probably some of our talking points. And so you get Kerry saying that, you get the Secretary General of the UN, Guterres, saying we're on a highway to climate hell with our foot on the accelerator.
And these statements are preposterous.
Yes, of course they are, okay? Even by the IPCC reports, they're preposterous. The climate scientists are negligent for not speaking up and saying that's preposterous.
Okay. On to another one of the aspects of things going wrong. You write in a way that I have never seen anyone write about computer models. I have never seen anybody make computer models interesting.
Thank you.
So congratulations, Steve. You did something, as far as I know, in the entire corpus of English language, nobody else has done it. Okay. So here I'm going to depart from Unsettled for a moment to quote from a piece you published in the Wall Street Journal not long ago. Quote, projections of future climate and weather events rely on models demonstrably unfit for the purpose. Explain.
Well, to make a projection of future climate, You need to build this big, complicated computer model, which is really one of the grand computational challenges of all time.
And I remind myself and our viewers that I'm now talking to a man who was provost of Caltech, whose background is in other words, you really understand this field.
I do.
This is not some, okay.
I wrote a textbook in the mid-1980s when the first PCs came out about how to do modeling on computers with physics. So,
So you know,
so I do know what I'm talking
yes.
about. Okay, and then you have to feed into the model what you think future emissions are going to be. And the IPCC has 5 or 6 different scenarios, high emissions, low emissions, and so on. Okay. If you take a particular scenario and feed it into the roughly 50 different models that exist that are developed by groups around the world.
So Caltech has a model, Harvard has a model,
yeah,
Oxford.
But, well, not only that, but the Chinese have a model, or several models, the Russians, and so on. Okay?
Got it.
So then you feed the same scenario into those different models. You get a range of answers. The range is as big as the change you're trying to describe itself. Okay, and we can go into the reasons why there is that uncertainty. And in the latest generation of models, about 40% of them were deemed to be too sensitive to be of much use.
Too sensitive?
That's right. Namely, you add the carbon dioxide in and the temperature goes up too fast, okay, compared to what we've seen already. All right? So that's really disheartening. The world's best modelers, trying as hard as they can, they get it very wrong at least 40% of the time.
Okay,
now,
go ahead.
I was going to say, this is not only my assessment. You can look at papers published by Tim Palmer and Bjorn Stevens, who are serious modelers in the consensus. And their own phrase is, these models are not fit for purpose, at least at the regional or more detailed global level.
All right. So I'm reading this, and I'm thinking, well, okay, fine, but we know Moore's law, maybe Moore's law itself doesn't apply any longer as we get to the atomic level of processors, but the general trend is still for processing power to expand rapidly. So I'm thinking these problems that Dr. Koonin is describing will become less and less and less, and then we'll get it. And then I read this passage. I am quoting Unsettled.
Yep.
And this is one of the most astonishing passages in the book. You're writing about the effects of the increases in computing power over the years. Quote, having better tools and information to work with should make the models more accurate and more in line with each other. Of course it should. This has not happened. The spread in results among differing computer models is increasing, close quote. This one you're going to have to explain to me. As our modeling power, as our processing power increases, we should be closing in on reliable conclusions, and yet they seem to be receding faster than we approach them. Have I got that correct?
That's right.
How can that be?
Because there are more, as the models become more sophisticated, what does that mean? That means either you made the boxes a little bit smaller in the model, the grid boxes, so there are more of them, or you made more sophisticated your description of what goes on inside the grid boxes. All right? And either of those are opportunities.
The whole globe is sort of divided up into
The whole globe is
boxes.
divided into 10 million really slabs, grid boxes. The average size of a grid box in the current generation is 100 kilometers, 60 miles. Okay?
Right.
And within that 60 miles, there's a lot that goes on that we can't describe explicitly in the computer. Because clouds are maybe 5 kilometers big, and rain happens here and not there within the grid box. We can't describe all that detail.
But one day soon we'll be able to.
Well, not really very soon. And let me explain why.
Right.
Okay. The current grid boxes are 100 kilometers. So you might say, well, why not make them 10? Well, suddenly the number of boxes has gone up by 100. Okay? So you need a 100 times more powerful computer. But it's worse than that, because the time steps have to be smaller also, because things shouldn't move more than a grid box in one time step. And so the processing power actually goes up as the cube of the grid size. And so if you want to go from 100 kilometers to 10 kilometers, that's a factor of 10, the processing power required goes up by a factor of 1,000. And it's going to be a long time before we got a computer that's 1,000 times more powerful than what we have today.
But am I wrong that in principle, it's all reducible to data and we'll get it someday?
Well, I think we will
You're
do
queasy
better.
even about that, though, aren't you?
Yeah, I mean, there are several reasons why I'm still queasy a little bit about that. One good example is weather prediction,
Right.
okay, which is kind of the same stuff, but
In other words, you feed data into
you
into
feed the
models,
current state of the weather into the model, and you can predict
Right.
what the weather's going to be tomorrow, next day, and so on. And we've gotten better and better at that over the last 20 or 30 years.
Right.
And so we now see forecasts that go out 10 days or something like that. Well,
Right.
they get worse as you go out, but they're at least made.
Right.
And so you might say, okay, it's going to get better like that. The main reason that that's gotten so good is the initial data. Namely, we know better and better the state of the atmosphere right now so that we can predict it going forward. Climate's a different problem. Climate is really driven by the oceans. Okay? We have not very good data on the oceans. And to be able to specify the state of the ocean now and then know it 10 or 20, 30, 40 years from now is a much harder and difficult problem. So it's not obvious to me we're going to get it right.
All
But
right.
it's worth trying, all right? Because only because it's a grand computational challenge and we will develop technologies and learn techniques.
We'll learn a lot
that
trying.
and will be helpful in other applications.
Okay. Steve Koonin versus the headlines.
Right.
So after reading your book, which I did this past spring, you and I are speaking in the middle of August, I just started collecting headlines, thinking, I'll just read this to Steve and see what he says about it. So the moment has come. CBS News this past May, quote, "Scientists say climate change is making hurricanes worse," close quote. Here's Koonin in Unsettled, quote, "Hurricanes and tornadoes show no changes attributable to human influences." Well, what do you think you're doing taking on CBS?
Well, you know, what science does CBS know? The media, if you'll excuse me, gets their information from reporters who have no or very little scientific training.
You mean you didn't graduate people from Caltech who went to work in the
Actually,
media?
there's probably one or so, and they do a good job.
All right.
They have reporters on a climate beat who have to produce stories. The more dramatic, the better. If it bleeds, it leads. And so you get that kind of stuff. I quote, when I say something about hurricanes, I quote right from the IPCC reports. And it doesn't say that at all.
All right.
Okay? Actually, the most recent report said it based on a paper which was subsequently corrected. So, okay.
Okay.
All right.
Floods.
Floods.
Here's actually, this is an old headline.
Yeah.
Here's a 2020 headline. This is from an article or press release published by the UN Environment Program. Quote, "Climate change," this is the UN now, not the IPCC, but it is a UN
Right.
agency. "Climate change is making record-breaking floods the new normal."
Okay.
Here's Steve Koonin in Unsettled. "We don't know whether floods globally are increasing, decreasing, or doing nothing at all." Close quote.
Well, what I would say is the UN needs to be consistent, and they should check their press release against the IPCC reports before they say anything.
All right.
All right. Again, when I wrote Unsettled, I tried very hard to stick with the gold standard, which was the IPCC report at the time or the subsequent research literature. And I had available to me when I wrote the book only the 5th assessment report,
All right.
which came out in 2014. As we've discussed, the 6th assessment report came out about a year ago, and I'm proud to say there's essentially nothing in there now that needs to be changed.
The
I
paperback
anticipate-
edition is not going to be totally rewritten.
No, I will do an update, of course, in
Okay.
the paperback edition.
All right.
Okay.
Agriculture. Here's a 2019 headline, New York Times. Quote, climate change threatens world's food supply, United Nations warns. And here's Steve Koonin in Unsettled. Agricultural yields have surged during the past century, even as the globe has warmed. And projected price impacts of future human-induced climate changes through 2050 should hardly be noticeable among ordinary market dynamics, close quote.
Not what I said, but what the IPCC said.
Okay, so it's
you,
one
you're
thing
seeing this game of
CBS
telephone. Well,
but
I can take current media,
right?
and almost any climate story I can write, I think, a very effective counter. It's like shooting fish in a barrel, all right? And I've actually gotten to the point where I say, oh no, not another one. Do I have to do that too? So this is endemic to a media that is ill-informed and has an agenda to set.
And what is their agenda?
The agenda is to promote alarm and induce governments to decarbonize. I think that probably their primary agenda is to get clicks and eyeballs.
Right.
And you know, there are organizations. It's wonderful. There's an organization called Covering Climate Now, which is a nonprofit membership organization. It's got The Guardian, and it's got various other media, NPR, I believe, and their mission is to promote the narrative. They will not allow anything to be broadcast or written that is counter to the narrative.
The narrative that the
We've
John
already
Kerry
broken.
narrative.
We've already broken the climate, and we're
The
headed
Mutual
for
Suicide
hell,
Pact.
et cetera. Right. Okay.
All right. So here, sit tight because I'm going to read you several headlines
Okay.
now.
I'll listen.
And these are headlines on July of 2023.
Mm-hmm.
So as you and I tape this is last month.
Mm-hmm.
Here are a few headlines I collected. The New York Times on July 6th. Heat records are broken around the globe as Earth warms fast. From north to south, temperatures are surging as greenhouse gases combine with the effects of El Nino, close quote. New York Times on July 18. Heat waves grip 3 continents as climate change warms Earth. Across North America, Europe, and Asia, hundreds of millions endured blistering conditions. A U.S. official called it a threat to all humankind. Wall Street Journal. Lest you think I'm going after the New York Times here, with the Wall Street Journal on July 25th. Quote, July heat waves nearly impossible without climate change, study says. Record temperatures have been fueled by decades of fossil fuel emissions. Once again, the New York Times, this is my last headline, this is on July 27, just a couple weeks ago. This looks like Earth's warmest month. Hotter ones appear to be in store. July is on track to break all records for any month, scientists say, as the planet enters an extended period of exceptional warmth, close quote. Unsettled came out in April 2021. So we will forgive you, Steve, because you could not have known in April 2021 what would happen last month, July of 2023. But now July 2023 is in the record books, and it proves that climate science is settled. That
statement, together with all those headlines, confuse weather and climate.
All right.
All right?
Give me a tutorial now.
Yeah, so weather is what happens every day, or maybe even every season. Climate, the official definition, is a multi-decade average of weather properties. Okay?
That's what the IPCC
Yeah,
is?
no, the World Meteorological Organization says that also.
All right.
Okay? Which is another UN agency. All right? So don't tell me about what happened this year, but tell me about what happened the average of the last 10 or 20 years. Okay? And then we can talk climate. Now, with respect to the unusual heat that we saw last month, right, there is observation.
You were in New York last month.
I was indeed mostly
so you
in
felt
New York.
it. It was
Yeah,
hot.
Yeah,
it was
hot.
hot.
Of course it was hot.
Okay, all right.
Okay. I wasn't in the city, fortunately, but still. And actually being in the city has got an issue, is a piece of the story. But let me continue. We have satellites that are continually monitoring the temperature of the atmosphere. Mm-hmm. And they report out every month what the monthly temperature is, or more precisely, what the monthly temperature anomaly is, namely, how much warmer or colder is it than the average, what would have been expected for that month, because in July it's expected.
And the average is at least over a decade.
Well, we have
longer.
data that go back to about 1979. So
Okay.
we have
All right.
good monthly measures of the global temperature, lower atmosphere, for 40-something years.
All right.
What you see is month-to-month variations, of course, but a long-term trend that's going up. No question about it. It's going up at about 0.13, 0.15, I won't get the number exactly right, degrees per decade.
All right.
That's some combination of natural variability and greenhouse gases, okay? Human influences more generally, okay? And then every couple years, you see a sharp spike. It goes up, okay? And that's El Nino, it's
see.
weather, and so on, okay?
When you say spike,
Yeah, it goes
Spike
up and down.
goes back down.
Correct.
We're not talking about
Correct.
to a new plateau.
No,
All right.
no. So there's a long-term trend, which is greenhouse gases and natural variability, and then there's this natural spike every once in a while. Pinatubo goes off, you see something. El Ninos happen, you see something, and so on. The last month, in July, there was another spike, okay? In the anomaly's about as large as we've ever seen, but not unprecedented, okay? Now, what the real question is, why did it spike
Right.
so much?
Right.
Okay? Nothing to do with CO2. CO2 is kind of human influences are kind of the base on which this phenomenon occurs.
So because the CO2, even if you stipulate that CO2 is causing some large proportion of this warming,
Slow, steady warming.
it's a slow, steady process.
Correct.
You would not expect to see spikes. You wouldn't expect to see sudden step functions.
Absolutely not.
All right.
And there are various reasons people hypothesize, we don't know yet, why we've seen the spike in the last month. One of the more interesting ones, I mean, apart from changes in El Nino and other oscillations in the climate
You
system.
better take just a moment to explain what is El Nino.
El Nino is a phenomenon in the climate system that happens once every 4 or 5 years. Heat builds up in the equatorial Pacific to the west, Indonesia and so on. And then when enough of it builds up, it kind of surges across the Pacific and changes the currents and the winds as it surges toward South America.
All right.
It was discovered in the 19th century, and it kind of well understood at this point.
19th century means that phenomenon has nothing to do with CO2.
Correct. Now, people
right.
talk about changes in that phenomena as a result of CO2, but it's there in the climate system
All right.
already. And when it happens, it influences weather and climate, weather all over the world.
We feel it.
We feel it. It gets rainier in Southern California, for example, and so on. So we have been in the opposite of an El Nino, a La Nina, for the last, 10 years or so, maybe longer. Part of the reason people think the West Coast has been in drought. And it is shifting. It has now shifted in the last many months to an El Nino condition that warms the globe and is thought to contribute to this spike we have seen. But there are other contributions as well. One of the more surprising ones is that back in January of 22, an enormous underwater volcano went off in Tonga. And it put up a lot of water vapor into the upper atmosphere. It increased the upper atmosphere water vapor by about 10%. That's a warming effect.
That's a lot.
That's a warming effect. And it may be that that is contributing to why the spike is so high.
So let me go back to New York, since you spent July back there. I happened to visit in July, and we have Canadian wildfires, and the press telling us that the wildfires are because of climate change. And for the first time that anybody can remember, you grew up in Brooklyn, maybe your memory goes back farther, but for the first time anybody I know could remember, smoke is so heavy in Canada, and it gets blown into New York, and the sky is, it feels as though there's a solar eclipse taking place. For 2-3 days, it's so dark in New York. Meanwhile, New York, I'm just giving you
Yeah,
sort of
yeah,
the
yeah,
human
yeah.
experience.
Yeah.
Meanwhile, New York is hot. It's really hot. And we're reading reports that Europe is hot. And there's sweltering even in Madrid, a culture built around heat in the midday where they take siestas. Even in Madrid, they don't quite know how to handle this heat. And it's perfectly normal for people to say, wait a minute, this is getting scary.
Right.
It feels for the first time as though the earth is threatening. It's unsafe. In New York, of all places, where one thing you didn't have to worry about earthquakes, but the other thing you didn't have to worry about was breathing the air, at least. LA, different, but suddenly you can't breathe the air. It feels uncomfortable. It's scary. It's scary.
I understand.
And your response to that is what?
So we have two responses.
Yeah.
We have a very short memory for weather. So you go back in the archives of the newspapers, and you can read from even the 19th century on the East Coast descriptions of so-called yellow days when the atmosphere was clouded by smoke from Canadian fires. Okay? So look at the historical record first, and if it happened before human influences were significant, you got a much higher bar to clear to say, aha, that's CO2. That's the first statement. The second statement is there's a lot of variability. Here in California, you had 2 decades of drought. And the governor was screaming, new normal, new normal.
Yes.
And look at what happened last year. Okay, record, at least historical record, torrential rains, because people forgot about the 1860 some odd event where the Central Valley was under many feet of water. Okay, so climate is not weather, and the weather can really fool you.
All right. Steve, some last questions here. Unsettled. Humans have been successfully adapting to changes in climate for millennia. Today's society can adapt to climate changes, whether they are natural phenomena or the result of human influences. So you draw the distinction between adapting to climate change on the one hand and the John Kerry approach on the other, which is trying to stop climate change. Explain that distinction and explain why you favor one over the other.
All right. I would take issue, though, with your description of Kerry's approach.
All right.
It's not trying to stop climate change. It's to reduce human influences on the climate, because the climate will keep changing even if we reduce emissions.
You're fairer to John Kerry than I would even dream of.
Okay.
All right, go ahead.
So let me talk about adaptation a little bit and give you some example that is probably not well known. At least it wasn't really known to me until I looked into it. If you go back to 1900 and you look from 1900 till today, the globe warmed by about 1.3 degrees. That's this global temperature record that everybody more or less agrees upon.
Is that Fahrenheit or Celsius?
Celsius.
Celsius, okay.
You can convert.
All right.
And you might ask, well, the other statement before we get to the consequences is that the IPCC projects about the same amount of warming over the next 100 years. And you might ask, what's going to happen over the next 100 years as that warming happens? We can look at the past to get some sense of how we might fare. Okay? Not perfect, but a good indication. Since 1900 until now, the global population has gone up by a factor of 5. We're now at 8 billion people. The average lifespan or life expectancy went from 32 years to 73 years. The GDP per capita in constant dollars went up by a factor of 7. The literacy rate went up by a factor of 4. The nutrition, et cetera, et cetera. And that we've seen the greatest flourishing of human well-being ever, even as the globe warmed by 1.3 degrees. And the kicker, of course, is that the death rate from extreme weather events fell by a factor of 50. Better prediction, better resilience of infrastructure, and so on. So to think that another 1.3 or 1.4, whatever degrees over the next century is going to significantly derail that beggars belief. Okay, so not an existential threat. Perhaps some drag on the economy a little bit. The IPCC says not very much at all. But the notion that the world is going to end unless we stop greenhouse gas emissions is just nonsense.
This is not a mutual suicide pact. in which we
No,
find
not
ourselves.
at all.
Okay. On August 16th of last year, a year ago, President Biden signed legislation that included some $360 billion of climate spending, at least the Biden administration claimed it was climate spending, over the next decade. President Biden, quote, "The American people won and the climate deniers lost. And the Inflation Reduction Act," which curiously enough, since it seems to have prompted inflation rather than reduced it, but curiously enough, that's what they called it, "The Inflation Reduction Act takes the most aggressive action to combat climate change ever," close quote. Good legislation? Was that a useful adaptation?
It's aimed at mitigation, by and large, namely reducing emissions. I think there are parts of it that are good, in particular the spur to innovate new technologies. The only way we're going to reduce emissions, if that is the goal, is to develop energy technologies that are no more expensive than fossil fuel technologies, but are low emission or zero emission.
Okay, so hold on. Let's take that one right
All right,
there.
let's do the R&D.
Because here I have a provost of Caltech who knows what we can reasonably hope and what we cannot reasonably hope.
Right.
Can we reasonably hope? You and I are talking after 10 days after the internet went crazy with some claim of cold fusion or no, it was room temperature superconductivity.
Right.
So is this a problem we can crack?
I think it's going to be really difficult. There is one existing solution, and that's nuclear power, fission.
Right.
We know about fusion separately. Fission exists.
Yes.
It can be done.
Right.
It's more expensive than others methods.
But because of the regulatory overlay,
And it's
isn't
got
it?
largely, right, but also because at least in the U.S. we build every plant to a custom design. So one of the things I helped catalyze when I was in the Department of Energy was small modular reactors. These are about the 10th the size of the big ones. You can build them in a factory, put them on a flatbed truck, and
this is not a crazy dream.
No, this is not a crazy dream
Is
at all.
venture money going into this?
A lot. And there are companies that are on the verge of putting out a test deployment of commercially constructed
So
ones.
why isn't John Kerry going to one of these hot new startups and doing a photo shoot and giving a speech?
He may have. I don't know. I mean, I don't follow Ambassador Kerry in detail. But
But isn't this the way? Isn't this the hope?
There is the nuclear word that is a political hot potato in some quarters. Again, not to get too much into politics, I think there is a faction of the left wing that just sees that as anathema and not a solution at all. Meanwhile, the Chinese are doing it. Okay. So I like the technology parts of the IRA. I do not like the subsidies for wind and solar, and let me take a moment to explain that. So there are significant incentives.
I keep saying you're a provost of Caltech. You're also an Obama guy.
An Obama guy. And one of the things I don't think you mentioned, I was chief scientist for BP, the oil company, for 5 years.
So you know the energy industry.
So I learned the energy industry. I never had to make any money in it, but I helped strategize and to kind of systematize thinking for them.
Okay, so
I know from the inside.
So subsidies to solar?
So subsidies to solar and wind. Everybody thinks that's a solution. Let me note that wind and solar are intermittent sources of electricity. Solar obviously doesn't produce at night or when it's cloudy. Wind does not produce when the wind doesn't blow. And if you're going to build a grid that's entirely wind and solar, you better have some way of filling in the times when they're not producing. Now, if it's only 8 hours or 12 hours you're trying to fill in, not so hard. You can build batteries and so on. But if you need to fill in a couple weeks, and we do see times in Europe, Texas, California when the wind is becalmed and the solar is clouded out. So you need something else.
Right.
And that means that the something else, which might be batteries, although I think that's unlikely, gas with carbon capture, or nuclear, the something else has got to be at least as capable as the wind and solar. And since the wind and solar are the cheapest, the backup system is going to be more expensive than the wind and solar. So you wind up running two parallel systems, making electricity at least twice as expensive. So what I like to say is that wind and solar can be an ornament on the real electrical system, but they can never be the backbone of the system.
Okay. What scientists, what many of your colleagues are up to or think they're doing. In Unsettled, you quote the late climate research scientist Steven Schneider.
Right.
Okay.
He's a Stanford guy.
Stanford guy.
Right.
This is Schneider writing all the way back in 1989. Schneider, on the one hand, as scientists, we are ethically bound to the scientific method. On the other hand, we are not just scientists, but human beings as well. We'd like to reduce the risk of disastrous climate change. That entails getting media coverage, so we have to offer up scary scenarios, make simplified, dramatic statements, and make little mention of any doubts we might have, close quote. Well, scientists are human beings. What's wrong with that?
I think Schneider's attitude, and I never met him, by the way, which is not uncommon among many people, is a advisory malpractice and is a usurpation of the right of non-experts to make their own decisions. And let me explain. The biggest problem in trying to reduce emissions is not the 1.5 billion people in the developed world. It's the 6.5 billion people who don't have enough energy. And you're telling them that because of some vague, distant threat that we in the developed world are worried about, that they're going to have to pay more for energy or get less reliable sources and so on. They should be able to make their own choices about whether they're willing to tolerate whatever threat there might be from the climate versus having round-the-clock lighting, having adequate refrigeration, having transportation, and so on.
Billions of people in India and China,
6.5 billion
they're still
people.
poor.
Right, absolutely. They're energy starved. So a great statistic, I don't think I have it in the book, 3 billion people on the planet of the 8 billion use less electricity every year than the average U.S. refrigerator. Okay? So fix that problem first, which is existential and immediate and soluble, and then we can talk about some vague climate thing that might happen 50 years from now.
But scientists must tell the truth.
Absolutely. Completely lay it all out. And we're not getting that out of the scientific establishment. I know that. Okay?
All right. Two more questions. Unsettled has been out for more than 2 years now. How have your colleagues responded?
Many colleagues who are not climate scientists say, thanks for writing the book. It gives me a framework to think about these things and points me to some of the problems that we're seeing in the popular discussion. I got some rather awful reviews from mainstream climate scientists, which disappointed me, not because they found anything wrong in the book, they didn't, but the quality of the discussion, the ad hominem attacks, the putting words in my mouth, and so on. So that wasn't so good.
The argument was, Steve Koonin, you're one of us. You know you shouldn't be saying this.
Yeah,
it may be true, but you shouldn't be saying this.
Yeah.
Right?
Steve, how could you? Okay?
How could you?
And my response to that is, first of all, I've been involved in science advice in other aspects of public policy, particularly national defense, together with some Stanford, former, now passed on Stanford colleagues. And I was taught that you tell the whole truth and you let the politicians make the value judgments and the cost effectiveness trade-offs and so on. My sense of that balance is no better than anybody else's. Okay, but the thing I can bring to the table are the scientific facts.
But you trust democracy.
Yeah.
You trust people to elect politicians who can, over time, they'll make a mistake here, they'll make a mistake there, they'll give a speech that's inflammatory, but over time, you trust them. And the colleagues who say, no, don't tell them the truth, we can't trust them to make the right decision.
Right.
That's fundamentally what's going on.
That's right. Yeah, scientists know better than everybody else. And, it's even worse because these are scientists in the developed world. And if you ask the scientists in Nigeria, India, and so on, you get a very different values calculus.
Sorry, in what way?
Well, their primary concern is getting enough energy for folks.
Right, okay. Steve, last question. It'll take just a moment to set up here. According to a Harris poll in January 2022, a little over a year and a half ago now, 84% of teenagers in the United States agree with both of the two following statements. They agree with both of these. One, climate change will impact everyone in my generation through global political instability. Two, if we don't address climate change today, it will be too late for future generations, making some parts of the planet unlivable. Close quote. John Kerry, Al Gore, Greta Thunberg, and on and on and on. You've got countless voices warning that climate change represents a genuine danger to life on the planet. And now millions of young Americans are scared, really scared. Surely this has some role to play in what we see, the suicidal ideation and the increasing unhappiness. I'm sure there are all kinds of, but surely this is part of what's going on.
There are two immoralities here. The one immorality is the treatment of the developing world, which we talked about already. The other immorality is scaring the bejesus out of the younger generation. And, it's doubly dangerous because it's mostly in the West and not in China or India. I've tried. I go out and talk in universities. And, of course, the audiences I talk to tend to be quantitative and factually driven.
Right.
But even so, the minds get opened up, the eyes get opened up. I think in the U.S., the problem will eventually solve itself because the route we are headed down is starting to impact people's daily lives. Electricity is getting more expensive. You won't be able to buy an internal combustion car in 10 or 15 years if you're here in California. People are going to say, wait a second, as they already are in Europe, UK, Germany, France. And I think there will be a falling to earth of all of this at some point, and we will get more sensible.
Okay, one last question. I'm sorry, still won't quite let you go. Your audience now is not a colleague of yours. Your audience now is an 18 to 24-year-old American, pretty bright, maybe in college, maybe not, but bright, reads newspapers or at least reads them online. Give me in a sentence or two, speaking to that person, speaking to an American kid or young adult, do they need to be scared?
No, absolutely not. I would quote the 1900 to now flourishing as an example. And I would say, you probably believe that hurricanes are getting worse, and then point them to the IPCC line and say, you were misinformed about that by the media. Don't you think that there are other things about which you've been misinformed? You can read the book and find out many of them, and then go ask your climate friends, how come it says that in the IPCC report, but you're telling me something else?
Steven Koonin, author of Unsettled. Thank you. For Uncommon Knowledge,